Assalamu alaikum warahmatullah. Good day everyone and welcome you all to our physics class today. The purpose of this class is to explain the lecture notes prepared and delivered by Engineer A.G. Ramat. It is for a course PHY 1201 General Physics Mechanics for Sciences and Basic Health Sciences student of Al Istiqamah University, Sumaila 100 level student. Actually, it is a 2-unit course as we can see, and the total lecture hours for the semester should be 30 lecture hours. Prepared by Engineer Abdullahi Garba Ramad, PhD, MNSE. Okay, let's look at what we have today. Conservation laws in physics. Conservation laws in physics. Okay, we have some laws that tend to conserve physical quantities. What do we mean by physical quantities? When we say physical quantities in physics, we mean measurable quantities, quantities that we can measure and obtain their magnitude, their size, and possibly directions, if any. These are quantities that we classify them as scalar quantities and vector quantities. Quantities like length, mass, okay, they are regarded as scalar quantities. They are measurable. We can enter a physics laboratory to measure their sizes. So we call them physical quantities. Some of them they have both magnitude and direction, like force, momentum. Okay, now when we say conservation laws, they are laws that conserve some physical quantities. Okay, examples of those physical quantities include the energy, linear and angular momentum are examples of conservative laws, meaning you have a law that tends to conserve energy. You have a law that tends to conserve linear momentum. You have a law that tends to conserve angular momentum. And even force, we have conservative and non-conservative forces as well. They say the laws preserve the total energy of a system regardless of any changes in the system. This means that the system does not exchange energy with its surroundings. It does not receive energy from its surrounding. It does not release energy to the surrounding. Okay, here are examples. Conservation of energy. We have law of conservation of energy, and this is a very popular law. It states that energy can neither be created nor destroyed, but it can be converted or changed from one form of energy to another form of energy. But to destroy energy completely is impossible. It is always conserved, meaning I can convert kinetic energy to potential energy. Okay, I can convert potential energy back to the kinetic energy, but at any point the total energy, kinetic plus potential, is always conserved, is always constant. I cannot destroy that. Conservation of momentum. Remember, momentum is also a physical quantity. It is defined as the product of mass and velocity. When I know the mass of an object and I multiply it by its velocity, it gives me the momentum of the object. If a bullet, for example, has a mass of 0.05 kilogram and it moves with a speed of 100 meters per second, then the mass of the bullet 0.05 multiplied by the speed of the bullet 100 meters per second will give me 5 kilogram meter per second. Now this measurement is what we call momentum of the bullet. Now we have conservative law, of course, that tend to conserve or preserve momentum, and we call that law of conservation of momentum. This law states that the total momentum of a system remains constant. You see, it remains constant, it's not changing, it's conserved, unless an external force is applied. Provided there is no external force acting on a system, all the forces in the system are the forces due to the system. Okay, they are not introduced into the system, then law of conservation of momentum applies. The next one is conservative forces. Okay, we say that forces can also be conserved. These are forces that do not depend on the path taken by an object, but initial and final position of the object. Okay, they are called conservative forces. There is S here, forces, because they conserve mechanical energy of a body. Examples of conservative forces are gravitational force and electric forces or electric charges. Okay, what do we mean by saying that the forces do not depend on the initial and final position? I need a material, the material I prepared, a very short one to explain that. We say that a conservative force is one for which the work done is independent of path. Regardless of the path the object is taken, the work done remains the same. In other words, the work done by a conservative force remains the same regardless of the specific path taken between 2 points. A conservative force abides by the law of conservation of energy. Now, I need a diagram to show you that. Let me go down. Okay, here is a diagram. Let's say I have an object at A and I have another object at B. Then I can take the object from A to B using path 1, and the work done in taking the object from A to B along path 1 is W1. Now I can also take the object from A to B using the second path. Can you see indicated by this? Okay, path 2, and I can also take it using path 3 as well. I can also take the object from A to B along path 3, and the work done in doing that is W3. Now, provided W1, W2, W3 are equal, then the force I use. For example, if the work done for W1, if my work done is 1000 joules, and W2, the work done is again 1000 joules, W3, the work done is 1000 joules, they are equal. So the force is a conservative force. Okay, the force in W1, the force in W3, the force in W2 is a conservative force. Okay, so they say conservative force W1 equals W2 equals W3. But if the force is non-conservative, you will get different values for W1, W2, W3. Okay, this is how we understand conservative and non-conservative forces. Okay, now let me go back to his material. Okay, then he said conservation of linear momentum. Okay, the principle of conservation of linear momentum can be stated in different ways. There are different ways of stating the law, and each one you take is correct. You can say, for example, the first one is in any system of colliding object, that is when two objects collide, they hit on each other, the total momentum is always conserved, provided there is no net external force acting on the system. Or if you like, you can say the total momentum of an isolated or closed system of colliding bodies remains constant. You can also say if two or more bodies, this is I not L, bodies collide in a closed system, the total momentum after the collision is equal to the total momentum before the collision. So in the second statement, they made mention of isolated or closed system. What is the meaning of isolated system? Here he explains. He said, closed or isolated system means a system in which no external force acts. You don't have any force except the force of the system. We call that closed system. We will see in the next